Hello, today we are going to talk about the ideal gas law. But first we have to define a real gas versus an ideal gas. So obviously real gases are going to have a shape and they're going to interact with other particles. For the purposes of ideal gas law, we are going to ignore those things because an idealized gas does not have a shape and occupies no space and independent from other particles, of course. So is that ever true? No. However, if we wanted to factor in the fact that gases do indeed have a shape, occupy a really nebulous amount of space, and are interacting with other particles, the calculations would get ridiculous very quickly. So this idealized state, quote unquote, allows us to not do a ridiculous amount of math every time we want to calculate something. So I think you'll be okay with ignoring those things as we go forward. So the ideal gas law, or PV equals nRT, is going to describe the behavior of an ideal gas with respect to pressure, volume, temperature, and number of moles. So our formula here is pressure times volume. So this is pressure, V is volume, shockingly. N is number of moles. R is a gas constant. And then T is temperature in Kelvin. Okay. So when we're using this formula, the pressure unit doesn't really matter. Not that you don't have to include it, but you can use any of them really. You just have to pair it up with the appropriate R value. So again, the R value is a constant and there's several of them, each tying with a specific or a specific pressure unit. So if you are wanting to use atmospheres, you have to pick the R constant that's for atmospheres. If you're using kilopascals, you have to pick the R number that goes with kilopascals, et cetera, et cetera. Volume has to be in liters. If you don't remember how to convert to liters by now, you really should, but you can scoot your decimal place 3 places to the left to go between milliliters and liters, or just divide by 1,000. Molar volume for a gas is 22.4 liters. That means that 1 mole of any gas is 22.4 liters. Obviously, again, this is if that gas is ideal. We are not factoring in all the other things that can influence that, but ideal gases, 1 mole of them is 22.4 liters. That's just what we're going with. At STP specifically, and STP stands for standard temperature and pressure. Standard pressure is 1 atmosphere and standard temperature is 273 Kelvin. Now you could go a little bit more specific. You could say 273.15 Kelvin, but for our purposes, we're going to use this one most often. Remember diatomics, please. By this point, you should have circled all of them on the periodic table and you should know what I mean when I say diatomic, but hydrogen, nitrogen, oxygen, chlorine, fluorine, bromine, and iodine all show up in pairs when they are by themselves. And quite often, hydrogen, nitrogen, oxygen, chlorine, fluorine, bromine, and iodine are in a gaseous state, which means they apply directly to the ideal gas law a lot. So when you're calculating N, or number of moles, you have to remember to factor in the fact that those are diatomic. Also remember that 1 mole is going to be a molar mass in grams on the periodic table. So if I give you a gram amount and I want to know how many moles that is to use the formula, all I have to do is divide by the molar mass to get that. You should be very familiar with looking at your periodic table to figure that out by now. So to do a simple conversion, just once again to practice it, how many moles are in 19.6 grams of nitrogen? We're going to do our handy dandy T-chart. Once again, our given number, 19.6 grams of nitrogen, is going to go there. Our placeholder 1 is going to go there. We want to know moles. We have to get rid of grams. So for every 1 mole of nitrogen, we have to look on the periodic table and figure out how much N2 weighs. Which, if we look at nitrogen on the periodic table, we know that one nitrogen weighs 14.007 grams, so we multiply that 2 and we get 28.014 grams. And then all we have to do is multiply straight across, divide by whatever's on the bottom. And we get our answer for how many moles of nitrogen gas exist as 0.700. Okay, so that should be a review. You should know how to convert between grams and moles by now. Again, if you still don't understand how that works, I will walk through it with you one-on-one, but you have to ask me. Now, our R constants, if you are using atmospheres as your gas pressure unit, you're using R equals 0.0821. If you are using kilopascals as your pressure unit, you are using R equals 8.314. And if you are using millimeters of mercury, you are using R equals 62.4. Yes, I will provide you with those numbers. No, you do not have to memorize them. They will be there for you, but you have to pay attention to which R you need to be using. Temperature must be in Kelvin, as I said before. If it is in Celsius, add 273 and you will be in Kelvin. So, practice problems. How are we going to get comfortable with these things? We are going to practice. So, let us recall that our formula is PV equals nRT. Given the following sets of values, calculate the unknown quantity. So we are given P, we are given N, we are given T. We want to know V. So here's how we do it. We plug and chug. We start plugging things in where they go. Our pressure is 1.15. We do not know B. We do, however, have the number of moles. R we are not given. However, given a list of R's, we just have to pick the one that applies to us. So let's backpedal for a second. If we go back, remember our gas pressure is in atmospheres. So if we go back, look, the atmospheric one is 0.0821. So we fill in 0.0821 for our R, and our temperature has to be in Kelvin. So we have to do 28 plus 273 to get us 301 Kelvin. Now it's just a question of solving for V. And assuming you plug off everything into the calculator correctly, you should get V equals 2.1 liters. So again, this is a plug and chug. You just have to put everything in the right area. Practice problem number 2. At what temperature? So if it's asking about temperature, temperature is going to be the unknown. At what temperature would 3.10 moles of nitrogen have a pressure of 4.25 atmospheres in a 35.0 liter tank? So you see what I just did here. As I was reading the question, I identified what I had. So given our formula, I am given pressure, I am given volume, I am given number of moles, not given R, but again, we have a list of those, and I'm asked about temperature. So I have all the pieces of information that I need to solve this. It's just a question of plugging it in where it goes. So 4.25 atmospheres, that's our pressure, times our volume, 35.0 liters, equals 3.10 moles times an R value. Now the R value is going to be the same because again, we're in atmosphere, so our R value should be 0.0821 times our temperature. And once again, we're asked about temperature, so that's going to be our variable, and we just need to plug it into a calculator to solve. And if you plug that into a calculator, you should get T equals 584 Kelvin. Yes, sig figs are still a thing. Yes, you should always be rounding to the appropriate number of sig figs. Again, if you are confused as to how I'm identifying things and where they go, please come talk to me about it. But my hope is that these shouldn't be too terribly difficult for you because again, it's just a plug and chug, okay? So I will talk a little bit more about this in class. I will see you later this week.